Hi boys and girls, and welcome to Mathematics Grade 9 Term 2's work. We are dealing today with similarity. Okay, my simple way of describing similarity, I'll just give you a simple example of two cornflakes boxes. When you have got two cornflake boxes with different sizes, of course, you can see that these two boxes are the same, but they differ with size. For example, I'm just going to draw a simple box of cornflakes and another one here. Of course, it's cornflakes. And it's good cornflakes. So this one is 1 kg and this one is 500 grams. So basically, these two things are similar. The difference thereof is just the size of the two, but the branding and everything and the product inside is similar. So basically, this is what we mean when we say things are similar. Even with triangles, we've got two similar triangles, but what's different about them is the size of the triangles. Okay, so when we say triangles are similar, there are two conditions. They are similar when corresponding angles are equal and when corresponding sides are in proportion. I spoke of two words that are very intriguing: corresponding. We need to understand, what does corresponding mean. Corresponding simply means, when we talk about corresponding angles, we're talking about angles that are in matching corners. For example, like with these two triangles, I've got an angle here and then I've got an angle here. So these two angles are equal because they are corresponding, they are in matching corners. And then we've got another one, this angle here is equal to this angle there simply because they are in matching corners. And this one is this angle here is corresponding with this one, therefore these two angles are equal simply because those angles are in matching corners. And then I spoke again about the word proportion. What does it mean? It means two or more ratios or fractions are equal. So we will see that as we are doing the corresponding sides of these triangles. So for now, I think we must just start easy with the corresponding angles to prove that indeed these two triangles are similar. So let's see, how are we going to prove that? Let's say, for example, they gave you these two triangles and they said these two triangles are similar. Prove. Remember, this type of math is a math where we write whatever that we do, we must have results for. Okay, so now we have got triangle ABC, which is similar to triangle PQR. So I'm going to say angle A is equals to angle P. One might ask why? Because they are corresponding. And at this point in time, they indicated with this dot that these two angles are equal. And because they indicated, they told us. So my reason will be, it is given. And then now I have got another angle, we've got other angles. We've got angle B and angle Q, which are corresponding as well. So basically, angle B will be equals to angle Q. Why? It has been indicated to me, and regardless, they are corresponding angles. And because it's indicated, I'm going to say given. And now I have got two more angles that they did not say anything about them, this one and this one. And now, because they are corresponding, I will say angle C is equals to angle I. I want you to note something. It is very important that you know that sum of interior angles add up to 180. So when I have two triangles and then I have already mentioned that this angle and this angle are equal and this angle and this angle are equal. For the fact that we know that the sum of interior angles add up to 180, the remaining angles that were not indicated that we equal, then we know that they are equal simply because it is the third angle of a triangle. Okay, therefore I'm going to say triangle ABC is similar. This is the sign of similar. Triangle PQR are similar. Why? Because three angles are equal. And then I'm going to write angle, angle, angle. Okay? And then I also continue because we know that another condition of proving similarity is the corresponding sides being proportion. And I said earlier that proportion simply means that two or more fractions are equal. So corresponding means the matching sides. Okay, I'm saying matching side because now I'm talking about corresponding side. So this side is matching with this side. So I will say AB divided by PQ is equals to, another matching side is BC divided by QR. Another matching side is AC matching with PR. And this is what we're talking about, that corresponding sides are in proportion. Proportion are two or more ratios. This is a ratio or a fraction being equal. Okay. After I have written this, then I will conclude with my reason. My reason, I will normally write it there, but because I don't have space, I'll just write it here. I'll say similarity, I'll say similar triangles. So my similar, I just wrote its abbreviation, similar triangles. So this is basically how you prove that triangles are similar. I hope that makes sense. So now we are moving on to the next set of similar triangles. I've got triangle DEF and XZY. Before I can go on to this set of triangles, I want to show you something that is very important. The order in which these triangles are written indicates that angles are equal and also the sides are in proportion. Let me show you how. The order in which are written, okay? It's very important. So it's ABC, triangle. It's triangle ABC, which is similar to triangle PQR. So the order, I'm saying that the order is very important. So angle A is equals to angle P. If you can check, angle A is equals to angle P. So the order is very important. It can easily guide you. And then angle B is equals to angle Q. Angle B is equals to angle Q. Angle C is equals to angle R. Angle C is equals to angle R. So the order is very important. Please take note. And one other thing, also the order works even with the proportionality of the corresponding sides. AB over PQ. And then BC over QR. Okay? And then AC over PR. And note, boys and girls, that this can also still be written as PQ over AB is equals to QR over BC is equals to PR over AC. So what I did there, I just switched, the numerator became the denominator and the denominator became the numerator. This does not affect the ratio. The ratio will still be the same. So what is important is that when you decide to use this as the numerator, then you must continue to use the corresponding sides as numerators and the corresponding side as the denominators. What I'm saying is, I do not want to see any of you having written PQ over AB, and then the next ratio you write BC over QI. Then you messed up the whole ratio altogether. So when you decide to use the corresponding sides, then be consistent. Let the numerator be the numerators and the denominators be the denominators. I hope that makes sense. Okay, because of space, I'm gonna have to erase all this so that we can address this issue of the two sets of triangles to do another example of proving the similarity. Okay, so now I've got a triangle. I've got triangle DEF, triangle DEF, which they say is similar to triangle XYZ, XYZ. And they have told me that angle D through these dots, see this dot and this dot, they are telling you that these angles are equal. And through this line here, they are telling you that those angles are equal. And do not forget that when two sets of angles in both triangles are equal, then the third angles are also equal. So when I prove similarity, this is how I'm going to go about it. I'll start with my angles here, particularly because they already indicated the angles. So I'm going to say, remember, the order tells you, and this is proof, that this dot and that dot. So I'm having angle D is equals to angle X, Y. It's indicated, so I'm going to say it's given. And then I'm going right along the order, this and that. Angle E is equals to angle Y. Even if you can check angle E and angle Y, they are equal. Why? They are corresponding angles, but in this case, the information is given. Alright, like I've mentioned earlier, that when two sets of angles in both triangles are equal, the third angles are also equal. So this angle and that angle, we say angle F is equals to angle Z. Why? It is the third angle of a triangle. Okay, so I'm going to say, therefore, triangle DEF is similar to triangle XYZ. Why? 1, 2, 3. I've got angles. All corresponding angles are equal. And then I'll say, therefore, corresponding sides are in proportion. Okay, corresponding sides, DE over XY. DE over XY. And then is equals to EF over YZ. EF over YZ is equals to DF over XZ. DF over XZ. And then I'm going to write my result. I will say similar triangles. So basically, this is how you prove similarity when you are dealing with the case of angles. So now let's see when you are given the sides and you are not given the angles. Like in this case, I've got two triangles that are similar. So I need to prove that they are similar. Remember, how do I prove that they are similar? My cases will be angles, corresponding angles will have to be equal, or corresponding sides will be in proportion. But in this case, I have angles, but I'm not given any information about those angles. So I'm just going to focus mainly on the sides and the values that I'm given. So I'll check the corresponding. Sorry about that. As I was saying, when you are proving similarity, we always consider two cases: corresponding angles must be equal or corresponding sides must be in proportion. So this case, we are focused mainly on the sides. So we are just going to check the corresponding sides. Remember, the corresponding sides meaning that the matching sides. So we have triangle, let's check. We've got triangle A, B, C, similar. Triangle ABC similar to Q, P, R. Remember, the order is very important. So when you have the order, then you don't have to worry much. Then you've got this over that. We are checking if whether they are in proportion. So we are going to say AB divided by QR. And now we are doing substitution. We have got the value of AB. We've got side AB, which is valued 28 millimeters, divided by QR, which is valued how much? 40 millimeters. And it gives us 2. So it means the ratio there is 2. It means that this size was enlarged by 2, or by multiplying by 2 each side. Like 40 multiplied by 2 to give me 28. But we want to see that each side, that will we get the value of 2. So what we're going to do, the order BC divided by PR. And then now we substitute the values of BC and PR. Where is BC? BC is 22 millimeters divided by PR, which is 11 millimeters. What is the value there? It gives us 2. And now we're moving on the order AC divided by PR. AC divided by QR, rather. QR. Now we are substituting the value. AC is 30 millimeters divided by QR, which is 50 millimeters. The fact that all these numbers, they give me 2, then it means that the corresponding sides are in proportion. In all cases, I'm getting 2. So I'm going to conclude. I will say, therefore, I will conclude and say, therefore, triangle ABC is similar to triangle QPR. Why? Simply because sides are in proportion. Sides in proportion. So I'm just gonna write prop. Then I know that you are saying proportion. That's very nice about mathematics. You don't have to write words in full. So just say sides in prop. Then I know you mean sides in proportion. So basically that's that about similarity today. So from now I will be doing 3 more examples of similarity, just so that we are able to grasp the concept. But if you already grasp the concept, challenge yourself, do more activities, and yeah, strengthen your knowledge. See you next time.